right triangles and geometric mean. All right, so in the figure below, find the exact value of x. Do not approximate your answer. So it doesn't want us to give any kind of rounding. It wants us to give the exact answer. So there are 3 similar right triangles in a figure. We will use similarity to solve for x. So they're showing you the 2 triangles that it's creating. So here's the triangle that's on the left, and here's the triangle that's on the right. So there's a kind of a medium triangle and a small triangle, and then there's the large, the entire triangle that it creates. And we've dealt with this too, where we can pull the 3 triangles apart. There's another video I created based on the similarity when you have an altitude. And they're not necessarily telling you the theorem for this one, but when we have an altitude of a right triangle, so altitude means it comes from the vertex like this, goes straight down, and it's perpendicular. So this is an altitude. This does create a very specific situation. So the altitude itself is the geometric mean. And when I put it in a proportion, the geometric mean goes on the bottom and then the top. And then the other 2 numbers are the pieces that it created on the bottom. So we have the left side and we have the right side. And this is exactly the proportion they wrote down here. And then we cross multiply. X times 1 equals 2 times 2. So we get x equals 4, which is exactly what they got down there. So this one, they're not necessarily showing you the altitude idea, but this is what it creates. If you have an altitude coming down from the right angle straight to the third side, to the other side, and it's perpendicular, so it's an altitude, then it creates this geometric mean. It is a geometric mean. All right, so let's go ahead and clear this and start. Okay, so here's my, so this one, it's also the same idea, and I'll put this on here. So this would be the geometric mean if they gave us the number, but they're not giving us the number, so this also creates another geometric mean, and it has to do with the similar triangles that we've played with before. So in this case, we can say that this is the geometric mean going down the side. We still need the altitude here in order for this to work. So we're still going to write this equation. So we have 6, oops, supposed to be on the bottom. It's actually okay if I went bottom or top to bottom, but I like to do it this way because it's the way I'm used to looking at it. So in this case, we're looking at the left side of the triangle. We can do the same thing on the right side. So now what we're going to do is if it's going down the side of the triangle, what we do is we first say we want the side connected to it, so 5, and then the whole thing, which is z. Okay, so if it's the side, then we go down that side, that's the geometric mean, and the first number we pull is the segment that it created, the altitude created, and then the whole thing, the whole bottom. All right, so now we're going to cross multiply. So we have 5 times z equals 6 times 6. So 5z equals 36. And now what we want to do is divide by 5 on both sides so that we can get z all by itself. And remember, they don't want any decimals, and they don't seem to be giving us anything as far as a mixed number either. So they just want 36 over 5. So we're going to say 36 over 5, and we're going to check this and see. It looks kind of funky, but all right, they accepted it. All right, next. Okay, so now we're going to go down the right side. So remember, we need this altitude for this to work because this is how we create these 3 similar triangles, like in that other video where we're separating the 3. So now this is my geometric mean going down the side. So I have z on the bottom, z on the top. These are z's, not 2's. So now I'm going to focus, since I'm going down the right side, I need to focus on this first segment it created, which was 2, and then the whole thing, 7. So now I'm going to cross multiply, and I'm going to find out what z is. So I have z times z, which is z squared. Crossing that so you know it's a z. And then 2 times 7, which is 14. I'm going to take the square root, which gives me z equals square root of 14. So if I break 14 down, all I have is 7 and 2. Well, that means that there are no square roots. So I'm just going to leave it the square root of 14. There's nothing else to change it into. All right, next. Clear. Okay, so let's find our geometric mean here. So now they're going back to the altitude being the geometric mean, since that's the number they're giving us. No matter what, in order to make any of these work, I need the altitude. So I don't need the total of the altitude if I'm working on one of the sides, but I need that altitude drawn in order for these to work. Because otherwise, if I'm using the sides like we did in the last two, if the altitude's not there, then I don't know what the first side is, because there is no altitude to divide it up into little pieces for me. Okay, so this is my geometric mean. So I'm going to go ahead and write it on there. And then let's do this so we have the left side and then the right side. So when it is actually the geometric mean, we just use the two pieces. But when it's the side, we have to focus on the side, the first side it created, and then the whole thing. Okay, so let's go ahead and cross multiply here. So I get 3 times 3, which is, and you know what? No, I wrote 3. I was going to write 9 because I was just doing the math out loud here. So 3 times 3 is 9 equals y times 4, which is 4y. I'm going to divide by 4 on both sides. 4's cancel, so I just have 9 over 4 equals y. Click this, and I'm going to go from 9 over 4 and check. All right, we finished that one. Happy day.